Good afternoon, my YouTube viewers. In this particular video, what we're going to be talking about is bitwise operators. And so basically, what bitwise operators do is they perform operational procedures on binary data, binary logic. So basically, the way a computer works is it works with a series of ones and zeros. And so, like, it's either on or off. So a binary numbering system is based on 2. So you've got like either a 1 or a 0, an on or an off, a true or a false, a yes or a no. And then so basically they have developed a numbering system based on just a base 2 numbering system. And this is a binary numbering system. And so computers are designed on binary numbering systems. And because of that, you have bitwise operators. So we've got 6 bitwise operators. So you've got the AND function, which it returns a true value if both values are true. You've got an OR function, where it returns a false if both values are false. You've got an XOR function, which it returns a true if the 2 bits are different, and a false if they're the same. You've got the NOT function, which inverts the bits of a single operand. You've got a left shift, which shifts the bits to the left by a specified number of positions. You've got the right shift, which shifts the bits to the right by a specified number of positions. And then so what we also have is you've got what you can use bitwise operations for. So you can use bitwise operations for flags and permissions, swapping 2 numbers without a temp variable, checking to see if a number is a multiple of 2, bit masking, or modulo of powers of 2. And so what we're going to do is we're going to actually go through a few sample programs just to give you an idea of how bitwise operators work. So the first thing we're going to do is we're going to input 2 integers. So we're going to input the first integer, and then we're going to convert that integer into a binary digit, and we're going to print it. We're going to input the second integer. We're going to convert that second integer to a binary digit, and then we're going to print it. And then we're going to print the 2 integers, A and B. So you can see what we've done here. So the first integer is 9, so it's going to be 1001. The second integer is 4, so it's going to be 100. And then we're going to talk about the actual bitwise operations. So with the AND procedure, so the bitwise AND is a binary 0, a bitwise OR is a binary 1101, a bitwise XOR is a 1101, and then we're going to invert A, so it's going to be 1010. You're going to invert B, it's going to be 101. So we're going to shift to the left A, so it's going to be 18. If you shift it to the left, then it's going to be 10010. And we're going to shift to the right B, and it's going to be 10. And so this is the actual code that we use to perform these bitwise operations. So I'll just leave the code on the screen a little bit so you can look at it and see how you use bitwise operations, and you can copy it if you want to copy it. So the next thing we have is we have flags and permissions. So this is, we're going to define a permission flag. And so you've got your read is 10, and you've got your write is 1, and you've got your execute is 1. So your user permissions is read or execute. And our user permission is 1, 1. And then we're going to print user permissions and write, and it's going to be 1. So we want to check if a user has a write permission. And the way that you have to do it is write and execute have to be the same. If write and execute are not the same, it says you cannot write. So what I did was I just made the write and execute the same. So if user permissions and write, print user can write. If user's permission else, print user cannot write. So we've got user permissions and write is true, but what we'll do is we'll do an execute here. We'll do an execute is 2. So the cell's running. So it's just being a bit awkward. Well, it's been a little bit awkward, so we'll move on to the next one and see what happens. So we're going to swap two numbers without a temp variable. So you've got A equals 5, B equals 3. A equals A XOR B, and B equals A XOR B, and A equals A XOR B. And then so you print A and B, and so A should be 3 and B should be 5. And that's how you actually swap the digits. So this one worked. We got this one working. And it says with write is 1 and execute is 1. It says user cannot write. So let's just try this again. It says user can write. But let's try this. Execute write is 1, 0, which is a 2. It says user can write. Try that again. It says user can write. Try 101. That's a 5, I think. So it says user can write. Let's try this one, 101. It says user can write. But you just keep playing around with it, and it's more difficult if you're working with binary. If you're working with binary, it's more difficult, but you can keep playing around with it. So the next one we have is you say check to see if it's a multiple of 2. So you got def. Oh, it says power of 2. Okay. So you've defined the function is power of 2. Return n is greater than 0, and n minus 1 equals 0. So print is power of 2, 8, and that should be a true. And you print is power of 2, 10, and that should be a false. So 8 is a power of 2 and 10 isn't. And it's much more difficult to work with bitwise operators than it is regular operators. And the reason why is because we normally use a base 10 numbering system. We don't very often use a base 2 numbering system, but if you want to work with computers, you have to learn to work with a base 2 operating system. And then so now what we do is we extract the last 4 bits and mask it. So you've got number, and then you've got the mask. It says extract the last 4 bits. So last 4 equals number and mask. So it says print last 4, and it should be 1100, and it printed last 4 1100. And the last one is optimize modulo for powers of 2. So x equals 29, print x modulo 8. So 8 times 3 is 24, and you're going to have a remainder of 5. And then 29 and 7, you're going to have a 5 as well. So that's just another way to work at it. And I personally don't use bitwise operators a lot, but I included the bitwise operators in this course just so you can get some information on bitwise operators. So thank you so much for watching this video, and I will be making a new video for you on Python very soon.